All right, this lesson is on directed line segments and modeling. Basically, what we're going to do is we're going to take a line segment like this, and we're going to proportion it into different parts and find out where those points will be. So before we do that, we need to understand about ratios and fractions. And remember, ratios are a comparison of two quantities. So when we write ratios, sometimes we write them as fractional. We look fractional. But we also write them like this. We have the ratio of boys to girls. We write 15 to 13, where we just write them as a comparison of two numbers. So we could be 15 to 13 is the ratio. Now, how many students are there in all? So when we add up all the students, 13 and 15, there's 28 students in all. So then when we talk about the fraction, we're talking about the part over the whole. So when we talk about a fraction of students that are girls, well, how many are girls? We have 13 girls, so the fraction is going to be 13 over 28. So that's when we talk about ratios. We need to understand the ratio is 15 to the ratio of boys to girls. So we have 15 boys and this colon and then 13 girls. But then the fraction is, if there's girls, it's the 13 over the whole. The other concept we need to understand is a directed line segment is a line segment that has direction. That means it matters where you start and which direction it's going. So in this case, it has two endpoints. So it does have endpoints, but this arrow shows us the direction. So in this case, it's just in a one-dimensional going on a number line from -3 to 4. So our endpoints are -3 and 4, but it is going in the direction of the positive. So it's going from negative to positive. In this case over here, our endpoints are at 1, -3 and -3, 3. But again, we're going from the 1, -3 up to the -3, 3. And that's why we have this arrow. So that's what a directed line segment is. So how are we going to use this? Well, here's an example where we're going to partition a directed line segment. When you say partition, that means we're just going to cut it into different pieces. So like if I had a board and I say I want to cut that, I want to partition it into thirds, you would say, well, I want to cut it into 3 equal pieces. That's partitioning it into thirds. In this case, we're going to partition it into a specific ratio. So when it says 4 to 5 ratio, that means if I have a board, and let's say it's 9 feet long, if we have a 4 to 5 ratio, then one part of the board is going to be 4 feet, and one part is going to be 5 feet. That's the ratio, 4 to 5. The portion of this board that's the fractional portion, though, would be 4/9 of the board, and this would be 5/9 of the board. So that's what we're talking about when we're talking about ratios and partitions. So in this case, what is the location of point F? So we're going to find a new point that partitions the directed into a 4 to 5 ratio. Well, in this case, we've got D is at -4 and E is at 5. And this is pretty simple because we have 1, 2, 3, 4, 5, 6, 7, 8, 9. It's already broken up into 9 sections for us. So the first section goes right here, that's 4. And then the next section is 5. So if we put a new point right there, then we have a ratio of 4 to 5. So 0 would be our new point in that scenario. Take a look at what if we had the ratio was 2 to 7. Now again, because it's already broken into 9, 2 plus 7 equals 9. So pause the video and see if you can just figure out where would the point, let's call it point G, is at a ratio of 2 to 7. Okay, as you can see in this case, G would be at -2 because we first go 2 and then we go 7. So the ratio is 2 to 7. Let's take a look at it if we're directing it on, here's a formula that they kind of walked you through the how to derive this formula. So there's a few things you need to know. So if you have a segment from Q to S, so I'm just going to draw, here's Q, and we're going to S. And we're told that Q is at -2 and S is at 6. And we want to partition from a 3 to 2 ratio. So the first thing we need to understand is the ratio is how we get this M and N. So whenever you see M and N in an equation, you're saying M is equal to in this case is 3, and n equals 2. M to n is when we're looking at a ratio. And then x1 is just our point, is -2, and x2 is our second point, 6, because we only have one coordinate. We're going to do this in the coordinate plane as well, but we're just doing it on a number line first. So here's the formula to find out r, which is the way point r is going to partition it. So you take m times x2, so this is 3, m is 3, and x2 is 6, so that's 3 times 6, and you add it to n, which is 2, times x1, which is -2, and you put that all over m plus n, which is our whole segment, 3, or our whole ratio, 3 plus 2. And then we just simplify that. So 3 times 6 is 18, plus a -4, all over 3 plus 2 is 5. And if we simplify that, 18 plus -4 is 14 over 5. So that is the location of point R, is at 14/5. And we could put that, I don't know where R is at 14/5, which is about 2 4/5. So another way to rewrite this section formula, you want to pause your video and put this in your notes. And a lot of times in your assignment and quiz, it's going to have this, but you want to have an understanding of what this is. So to the section formula, if we have a coordinate plane, in a coordinate plane we have x, y points. So in this case, we have 2x. If I drew on a coordinate plane, and I have a point here and a point here, one would be x1, y1, and one would be x2, y2. Now the difference between when we're finding distance or things like that, a lot of times it doesn't matter which one you label as x1, y1, and x2, y2. In this case it does, because where you start is x1, y1, and the direction the arrow points, that's going to give you x2, y2. So make sure you do understand that. And then m and n, remember, that's the ratio. So if it gives you a given ratio, m is the one on the left, n is the one on the right. And then we're just going to substitute that in. So write that in your notes. So let's do this one. This is again with just a line. So we're going to find point A, D to E is a 5:6 ratio. So if we're going to use our formula, so we're going to say F, our point F, is equal to, and now remember we go back up to here and we just have an X point. So I'm just going to use this one. So X equals M over m plus n times x2 minus x1 plus x1. So basically what it's saying is we're taking the partition of the first ratio over the total, the fraction. We're going to times that by the total distance, which is x2 minus x1, and then we're going to add it to the beginning distance. That's what that's saying. So if I just substitute those values in, I have 5 over 11, and then I have my 2 points, 5 and -4. So the arrow's going this way, so I put 5 minus a -4, and then I'm going to add that to a -4. So we're going to take 5/11ths of this whole distance, and the whole distance is 9, and we're going to plus -4 is just -4. So this is 45 over 11, and I'm going to put them both in 11ths. And 4 turned to 11th is 44/11ths because I times them both by 11. If I timed by 11 over 11, then that's equivalent fraction. And 45 minus 44 is just equal to 1/11th. And that's how we find it. So even though this formula may look confusing, it really isn't. It's taking the portion, how far you're going to go, the first part of the ratio, over the total, timesing it by the distance, and then adding it to the beginning to get where our point is. So now we're going to do it on a coordinate plane. Put that down a little bit. On a coordinate plane. So in this case, we have two different points. We have L is at -6, 2, and N is at 5, -3. And you'll notice the directed line segment says we're starting at L and going to N. And then the ratio of the partition is 2 to 5. In other words, we're going to go 2/7 of the way down and 5/7 the rest of the way. We want to find where that point is. So M to N is 2 to 5. So now we're just going to use our same formula that we were just using. The difference is we've got to do it twice. So X is equal to M, which is 2, over 2 plus 5, M plus N. We're going to times it by the difference between x2 minus x1. Remember, we start with the where we're going. So that's 5 minus a negative 6. And then we add that to where we started from, which is at a negative 6. Now, if I simplify this down, I'm going to get 2/7 times 11 minus 6. So I have 22/7 minus, and 6, if we times that by 7/7, we get 42/7. So 22/7 minus 42/7 is a negative 20/7. That will be what our x value is right here, is negative 20/7. So I want you to pause the video and use the same thing, but now we're going to do using y. So use your y values and put it in and find out what it is. All right, check your work. You should have got 4/7. We used the same formula, m over m plus n. Then we use the y coordinates, making sure we use y2 minus y1 and adding 1, and we get 4/7. Okay, sometimes it actually gives you a fractional part. It says it's 1/4 of the length. If this is the case, then you don't have to do m over m plus n because it's already given to you as 1/4. So that first part is kind of taken care of. So if we take a look at this, we're going to look at these points. A is at -5, -1, and B is at 4, +1. And again, notice the direction it's going is this way. So this is our x1, y1, and our x2, y2. So they were giving us our m over m plus n, so we just say 1/4 times, and we're going to go x2, which is 4, minus x1, a -5, and then we're going to add that to our x1. So we have 1/4 of 4 plus 9 minus 5, so that's 9/4 minus, and 5 is 20/4. So that gives me a -11/4. Now, if you'll notice on our problems right here, only one of them has a -11/4, so I know that's going to be the answer. But if you want to pause and check to make sure that y value works, do that as well. I'll pause right now and do it. And if you look up here, here's my work, and it does work out that way. Now here's another one. I want you to pause the video and try this one. Again, notice that it has 5/6 given to you, so it's giving you the m over m plus n, and then it also says round to the nearest tenth. So keep that in mind. Okay, if you'll notice, if you should got -3.5. Now I'm going to show you how I do it with a calculator. I'm going to set this up first. So y is equal to 5/6 times 3 minus a -1 plus a -1. So that's 5/6 times 4 plus minus 1. Now if I pull in my calculator, let me just show you how you can do this on a calculator. So if it's asking for the nearest tenth, so 5/6 is the same thing as 5 divided by 6. So I can just go 5 divided by 6 times 4 minus 1. And it knows order of operations, so our nearest tenth would be 2.3. So I want you to pause the video and try this one. Again, this is a rounding to the nearest tenth. But this one gives you a ratio, 3 to 10. So you've got an m and an n in this case. So pause the video and try to work this one out. All right, rounded to the nearest tenth, you should have got -2.6 and 5.2. So let's take a look at if we're going to do this as applying this problem. So here we're going to look at it the same way. We still have a ratio. We have a starting point and an ending point, and we're going to round to the nearest tenth. So I want you to pause and see if you can work this one out using the same thing we've known. We only have an x value, so it should be just one equation. All right, this one makes it kind of easy because 5 minus 0 plus 0, so we just do 7/12 times 5 and we get 2.9 miles. All right, here's another example, and I want you to notice the endpoints of 6, and this should be 25. Pause the video and try this one. All right, you should have got 19.3 meters. So there's one more example about partitioning more than once. So I want you to read through this and see if you can set it up and then come back and we'll walk through it. So I've drawn this picture here. First it's saying we're going from K to N and we want to point L. Once we find L, then we're going to go from L to N and find M. So pause the video again and see if you can find the right answer. Okay, if you'll notice I found L first. Here's the work for that. Once I knew L, I used L and N to find M. And here's the work. So pause and walk through and make sure you understand how to do that if you partition twice.